Hi, welcome to my YouTube channel. I just made a cool thing I wanted to show off. So here's my attempt to making a multiplayer game from scratch, multiplayer online game. And this is what I got so far. One thing I wanted to show you all is that I encountered the problem making this. So you can see the server simulation right here, and this is my client. Potentially there could be like a lot of clients, but so for now we got one. So if I shoot and stuff, you can see it happens, though if I do it too much and like do it like this, you can see the bullets just moving randomly to, you can notice that they move to the position of the previous one. So it's kind of a problem of states interpolation. So the reason that it happens, let me just turn these off. So this is like the solution. I shouldn't have shown you this. The reason this happens is that you can see if I can find it. Okay, so here when you press the space, if you press the input space and you got some time after you shot your last bullet, so basically there is a cooldown that you can't shoot at a faster rate than this cooldown, you get to append a bullet to the list. Here is the list, and you append it based on the player's rotation position and all that. And when the bullet goes out of screen, you can see I append it to a list, and then I just remove all the bullets that went out of the screen. So and then if you have the notice, let me just run this one more time to show you. So you may notice that the server this is the server. I told you that already. If you look closely, you can see the spaceship on the server is not refreshing as fast as this one on the client. So if I just move, this one is very smooth, and this one is kind of laggy, I suppose. The reason for that is because I don't want to put a lot of pressure on the server. The server runs on 10 FPS, then the client receives updates, and it interpolates between the last two received snapshots. Yeah, snapshots. So we get this smooth effect on the client side, even though the server is not running as fast. Anyways, this is the interpolation is the actual issue here, because when there is a let me explain it like this. When the bullet goes out of screen, it gets removed, right? So there is a point in time at which the previous state, which we are interpolating from, has a bullet, or at least has a list of bullets. Like let's say it has 10 bullets in it, right? And then in the next state, the state after the moment we're talking about, that bullet is removed. So we get into this weird state that we need to interpolate between the previous bullets to the next bullets, and they don't have the same number of elements. So why to explain why exactly this happens, and I'm gonna just show you this one more time so you can actually see it just happen. If I do this, Did you see that? The interpolation is doing some kind of weird thing that just makes this whole experience weird. So the reason that's happening, let me show you this. You can see the to-do I already have here, but so what I'm doing is that I basically say, hey, if the length of the previous state, this is the previous state, S, and this is the next state, and we're lerping in between them. So I'm just checking. This is for the players. Don't worry about it. I'm just checking that if they are the same length, meaning no bullet is removed or added, interpolates all of them, assuming that the index that points to the previous bullet is the same as the index that points to the bullets to that one bullet after the update. So basically, I'm assuming no bullets are kind of swapped in the list. Basically, my I is the ID of a bullet or the identity. So this check ensures that we don't do out of bound indexing and stuff, so our program doesn't crash. But there is a special moment that this if statement is not sufficient enough, and that's when you have the states that are just happening in the middle. You have a list of bullets, and then one of the bullets goes out of the screen, and at the same time you shoot one bullet. So if you imagine it like this, then this goes out, this comes in, you still have the same length, but all your bullets were shifted one to the end because that one was removed, and you have a new one at the beginning. So the identity just the one I just explained that we have an assumption right there does not hold true anymore. So we get to this weird state that your bullets are just shifting backwards somehow. To fix this, there's an interesting solution. So if I check my bullet list, I go to the struct, you can see that the bullet has a translation, which is basically the same thing as a position, and a rotation, basic things for a bullet to have. But if I check out to the latest version that has it solved, you can see I added an ID field. The purpose for this is to just identify what bullets we're talking about when we are interpolating, when we are lerping. So just to show you some bookkeeping, where is it? Okay. So, we keep track of next bullet ID, then when we spawn new bullets, when we spawn new bullets, we assign that next bullet ID to that, and then just increment the next bullet ID. So just basic stuff. So our first bullet is gonna have an ID of 1, then the next one is gonna have an ID of 2, and so on. And the real challenge is to get this lerp working properly. You can already see the entire function has changed, and this is an interesting solution. So if you just want to do it naively, then you can do a double for loop, and for each bullet in the previous state, figure out what bullet corresponds to it in the next state, and then lerp that and then continue to the next bullet, right? But that's just gonna be O of n squared, right? So we don't want to do that. What we're gonna do is to use some algorithm. I think it's called double pointer algorithm. Let me just check real quick. Double pointer algorithm. It's a kind of a general term, I guess. Yeah, so you can just read about it on the Geeks for Geeks website. But let me just explain this for you in a nutshell. So let's assume our previous state consists of bullets with these IDs, and the next state consists of bullets with these IDs. So because these IDs are kind of sorted from the smallest to the largest anyway, because of the bookkeeping I talked about, we always increment it and assign it to each spawned bullet. So we can keep track of a pointer that like points to the first element right here, and keep track of another bullet that points to this index right here. So we do a check. We say, first off, we run a for loop that ensures none of these pointers go out of index, and so therefore we don't have any panics or all that and all that. So the algorithm works like this. You got two pointers pointing to the first element, then you compare the ID of the bullets you're pointing to. Then once you compared it, you increment the pointer of the one that has a smaller index until you or unless you found two IDs that are equal to each other. So let's quickly run through this example. We are pointing to 1, we're pointing to 2. 1 is smaller, so we just increment this pointer. So now if we compare the IDs again, we see that these are equal. So we do the lerping and stuff like this. You can see the line. By the way, the algorithm is just right here. You can just look at it. We lerp, and then this is a special case because we have lerped. We increment both IDs so that we just move on. Now the smaller ID needs to catch up. So we increment the second pointer, and we got equal IDs. So we'll do the lerp again, and we increment the two pointers once again. These are equal to, we lerp between those, and just increment the pointer. Again, 7 is smaller than 8, so we increment its pointer. We went to 10, and so we increment the smaller pointer. And now if we just increment this, it goes out of index, and therefore our for loop is over. It doesn't hold to this condition anymore, and we're done without doing O of n. This algorithm just happens at O of n, which is pretty cool. So that's just what I wanted to share with you all. And in case you just want to check out what I've worked on so far, I've been doing this for I think about a month now. So why is this not showing up? Yeah, this picture is just outdated. Don't look at it. But anyway, this is the link of the repository. Store it if you like. Whatever. I'm gonna put the link in the description. Also, follow me on Twitter, by the way, #@ as the Primogen says. Here's my Twitter handle, whatever. Twitter page, I guess that's what they call it. And yeah, peace.